started.
Hi, Miss.
Hello, how are you doing?
Good.
Woo!
Inside.
All right, so here we go. I have a straight edge because I'm going to draw some straight lines today. But if you don't have a straight edge, that's okay. Just make them as straight as you can. And we're definitely taking notes. We're not doing any heavy drawing, so I just have all my colored pens. So here we go. Let's get started. I'm going to start off with what looks like a graph paper grid. Okay, so we're going to do our XY coordinate grid.
I thought you said we weren't drawing.
We're not, that's it. That's like all the drawing we're doing. Is we're doing this and then a straight line, and that's it. No heavy drawing today. There we go. All right, and we're going to start with, I'd like you to title this section slope. And today I want to see how loud you can get.
How loud?
Yes. When I write or say something that you recognize, even if you don't really remember everything about it, but you're like, I've seen that. What I want to come out of your mouth is, oh yeah! Like the Kool-Aid guy. Okay?
Oh, yeah.
So, is slope a familiar word?
Oh, yeah.
All right. What do you remember about it?
I don't know.
That's okay.
It's an inclined
It's an inclined thingy.
It's something that goes all the way down and comes back.
Goes all the way down and comes back. And then you're doing this thing with your arm. We got some stuff going on with the arms. All right. What if I write this? Is this familiar? Rise over run.
Oh, yeah.
I like it.
Who like it
Today. I like the noise today.
I don't like it.
Rise over run. You
It's
can
supposed to be silent and quiet.
you can also say the change in y divided by the change in x. Is that familiar? No. Okay.
Oh no.
Oh no. That's
Yeah,
okay.
I see it.
A little bit. Well, then where's my oh yeah?
Oh, yeah.
All period.
No.
No, just 20 minutes. Just 20 minutes. All right, let me give you the formula for this thing when you have 2 points, okay? Here's the formula, y2 minus y1 over x2 minus x1. Is it familiar?
Yes.
Okay, do a quiet oh yeah. Thank you. Go. Give me a quiet oh yeah. Oh yeah. All right.
Oh.
Is that a little better?
Stop that.
All right. But this formula is important. So I want you to come over here to the left and put your little star. And we're going to write here slope formula. Gentlemen, keep the conversation on topic, please. This is so important that not only are we going to mark down the little star, not only are we going to write on the left, we're also going to circle it with a highlighter. It's that important.
Oh, yeah.
All right. Linear functions, slope and equations. I need some points.
Okay. F. What do you want?
Okay, we can call it F if you want. Give me some coordinates for this point. Two positive numbers, please.
2, 1.
2, 1.
What do you want?
That's like 9, 10 right there.
All right, and I need some other ones, but these are negative, so I need 2 negative numbers.
Negative 9, negative 10.
All right,
Salud.
bless you.
Thank you.
This is not to scale.
It's not.
No,
It's okay.
It's funny.
It's drawn by my mother's favorite map maker, Noto Scale, not to scale.
I get it.
He's Italian.
What do you want?
All right. So now we have 2 points, and we have a formula that lets us generate the slope of a line if we know 2 points. So we're going to do that, but remember, since we're in geometry, not just algebra, we need to justify and give reasons for everything we do. So there's my reason bar.
Because you know some people don't have reasons for what they say.
And we're going to start at the very beginning. I have a song for that. Are you ready?
What?
Let's start at the very beginning.
I wish we could. But you
Very
said
good
no,
place
but you
to
know,
start.
start.
So we're going to start with the slope formula. What's the slope formula again?
y2 minus y1 over x2 minus x1.
Lovely.
Ow.
Yeah.
What does that equal?
There's our slope formula. All right. Which point is x1, y1?
Which point is x1, y1?
Yes.
The F.
Okay. And here's the trick is that he said the point F, and someone else was going, but I want this one to be x1, y1.
That's too bad.
And you know what? You're both right. So it doesn't matter which one you pick, but once you pick one, you're locked into that. So we're going to go with your offer. There's x1, y1, which means that this one must be x2, y2. Once you make that selection, you're locked in. Before you make it, you have complete freedom. All right, so what's the value for y2? -10. And y1? 1. The positive 1. And x2? -9. And x1?
2.
Lovely. And what did we do? What was this called?
Substitution.
Substitution. I was writing it real slow, hoping you'd guess it before I got to the end of the word. It was like hangman. All right, now that I've done my substitution, I'm going to zoom in real tight here so that you can see all my work. All right, -10 minus 1 is?
1.
9.
It's negative 11.
It's -11. Remember, negatives are like you owe me money. So if you owe me $10 and you borrow one more, how much do you owe me now? 11. So -10 minus 1 is -11.
What if you borrow $10 to pay their $10 back?
Then you don't owe me nothing.
No, they still owe you another 10.
What's -9 minus 2?
Yeah, 7. -7.
7.
7?
-7.
I get 2.
Which one?
-7.
Go to your calculator. Use the scratch pad. Double check.
I know what I do.
Go to your calculators.
Wait,
Use
wait.
the scratch pad. Double check.
Did you say -7 plus 2?
-11.
What?
-11 is what she's saying.
-11 minus 2?
Okay, and she's showing me the scratch pad. Okay.
-11 minus 2.
Oh, yeah.
-9 minus 2.
Oh, yeah. I forgot.
This was subtraction.
She ain't afraid.
Now what?
It's -13.
I have -11 divided by -11.
-1.
No.
Positive 1 or negative 1?
Positive 1.
Positive 1, because a negative divided by a negative is a positive. Lovely. Look, Ma, it's a slope.
What?
We're done?
We're done with the slope. Look, Ma,
No more video?
it's a slope.
It is.
It is a slope.
Does the slope have no hang?
All right. Down here, I'd like you please to write forms of linear equations. And this is another spot for you guys to give me the oh yeah. So I'm going to write the 3 forms of linear equations. I'm going to write their names. And if the names are familiar, you've heard it at least once somewhere before this class, I want you to give me an oh yeah. Okay? First one is point slope.
Actually, I've never
Is
heard
this
that.
one familiar?
No, actually,
No.
no.
Okay. Yes? Okay, give me your oh yeah. He gave it for you. He did it for you.
Maybe.
Here's the next one. Slope, intercept.
Oh, yeah.
All right.
That's a little too happy.
Awesome. I like it.
See, that was too much to argue with.
Here's the last one. The last one is standard.
Oh, yeah.
Nice.
Oh, yeah, that was kind of hard.
Oh, yeah.
Good job.
All right, and I'm putting little division bars between them, separating them out a little bit. I'm going to zoom in on point slope first. You'll get a chance to write that third one in a bit. You'll see it again. Yeah, I'll show it. I'm going to write the actual form with the algebra symbols, and if those forms look familiar, I want you to give me a...
Oh, yeah.
Thank you. Here we go. Y minus y1 equals m times the group x minus x1.
What?
That's point slope. Does it seem familiar? No. Okay. Slope-intercepts.
Hello,
Yes, ma'am.
I need Veronica Salinas. She'll be leaving.
Thank you.
Thank you.
Catch it on YouTube, okay? All right. Yes, sir.
Why is it Y and Y1?
I'm so glad you asked. So his question on this one was, why is it Y and Y1? If you've got like an X1 or a Y1 in this context, we're talking about the X coordinate and the Y coordinate of a specific point, just like we used in slope. If it doesn't have the little sub number, it's the variable and you have to kind of leave it alone for the moment. Okay. Slope-intercepts form is y equals mx plus b. Familiar? Give me my, oh yeah. Oh yeah.
Oh, yeah.
Oh yeah. Okay. I'm going to scoot it over so you can see slope-intercept and standard. That was the third one. If you didn't get a chance to write standard, that was the third one. Standard form looks like this.
I know that one.
ax plus by equals c. Is this familiar?
All of it.
Say, oh yeah.
Oh yeah. Say it for me, kid.
Oh, yeah.
Oh, yeah, we got
There's something interesting about the standard form, though.
Right.
So since it's interesting, I'm going to use an exclamation point. Here's the interesting thing. The numbers that are being represented by the letters A, B, and C that are in capital, these are whole numbers. Which means if I ask you, hey, write the equation of a line in standard form, and you make it look like this, but you give me fractions or decimals, I have to count it wrong.
So it has to be only like single digit.
It has to be whole numbers. Okay? They can be in the thousands or in the millions, or they can be single digits. They just can't have fractions or decimals. They can be positive or negative. I don't care as long as they're whole
Okay,
numbers.
Miss, what if it doesn't have a decimal, but it's 0.8?
Then it would just be the number 8.
Yeah.
Okay. There's also something interesting about slope-intercept. Do you want to know what's interesting about that one? It uses a slope and an intercept. I think I added an E at the end of that word. Pretend that's not there. Okay, gonna scoot it over so we can see point slope. There's something interesting about point slope. You want to know what that is?
What?
It uses a point and a slope as evidenced by its name. And since there are 3 interesting things on that line, over here I'm going to put 3 exclamation points. So when I'm going back and I'm studying and I'm reading my notes and I'm looking at that area, I realize there's 3 interesting things there that might be important for me to know. Okay. So I'm going to zoom out a bit so that you can see the whole thing. There it is. All right. In Algebra 1, you might have seen a problem that said this. Write an equation of the line with slope 1, and I'm using the information from the graph right above this, okay? Slope 1. Try to keep those conversations on topic, please. Thank you, appreciate it. And containing the points -9, -10, and 2, 1. Okay. Now you may have done this before in Algebra 1. Does something like this look familiar? A little bit? Or was somewhat? It's been so long you forgot. Okay, well we're going to do it, and as we go, when you get an oh yeah moment, go ahead and go, oh yeah, because you remember this. All right, and I'd like you please to take the rest of the space that you have, and we're going to break it into 3 sections. I'm going to do one kind of skinny, and I'm going to do one kind of medium, and then I'm going to leave the rest big. And this last section that I'm dividing with is going to be my justification. So that's going to be in my blue for my justification bar. I did this side in pencil so that you know. All right. So I want to ask the question, what's given in the question, in the problem that's being posed to us? Right here, the right in equation of the line. What information are we being given?
That, the points, it's giving us the points.
Okay, it's giving us points. Points are given. What else is given?
An equation.
We're not given an equation. We have to write the equation. I agree with you. The word equation is in there, you're right. So we know that we have to have an equation at the end. So it's got to have an equal sign in between some stuff.
Piero.
It gave us points
Slope.
and a slope.
I said it.
Awesome. So it gave us some points and it gave us a slope. Which form of the equation of the line can we use with points and a slope? Which form of the equation of a line, up here at the top of the screen, can we use if we've got a points and a slope?
Point slope.
Point slope. Beautiful. So that's where we're going to start. Point slope form. So I'm going to write it. There's the point slope form of the equation of a line. And so I'm done with that, and I'm going to underline it with a color. Now what?
We need another slope.
We need to put the numbers in there, yeah? All right, thank you. What's that called when we put the numbers in there for the letters?
Point.
Yeah, substitution. That's what you were going to say, right? Substitution. So what is M? What's the value of the slope? Look at the problem. What's the slope that we've been given?
2. No.
Here.
1.
1. So M is 1. What's the x coordinate and the y coordinate of the point? Now they've given us 2 points. And yes, at the top of the paper we decided which one was x1 and y1. But now that we're here and it's a brand new problem, we get to pick again. Which point do you want to be x1, y1?
21.
21? The 2, 1. This one again?
Yep.
Okay. And again, it was completely right if you had said the other point. Okay? All right, so that's what I'm going to substitute in. There it is. I did my substitution. Now I want to ask you guys, did the question tell you what form of the equation of a line it wanted you to write it in? Did it tell you what form it wanted the answer in?
No.
No, it just said write an equation of a line. Did we write an equation of a line?
Yeah.
It's in point slope form? Okay, so we're done. If you get asked, especially in this class, write the equation of a line, and I don't tell you what form, pick the easiest one to do, and you'll be right every single time. Now, what if it said, write it in slope intercept form? Now we have a little bit of work to do. Just a little bit, because we need to make this thing here look like this thing up here, which means y is all by itself on one side, everything else is on the other. We have a number multiplied to x, and then we're adding or subtracting some other number. That's what that form looks like, yes? So that's what we need to make this do. And the first step to doing that is to handle this multiplication right here with distribution. So I'm going to distribute. Now, do I need to write this 1 here?
No.
Why not?
Because when a variable by itself, it's always 1.
Because when a variable's by itself, you can always kind of pretend in your head that it's being multiplied by 1. Because 1 times anything
Is itself.
doesn't change that thing that you were multiplying it to. Okay? All right. So from here on, I'm going to drop that 1. I'm not going to write it. I don't want you to be confused. Okay, I'm almost done. I need to get rid of that subtraction by 1. How do I do that? What's the opposite of subtraction?
Addition.
Addition. What's the number I'm trying to get rid of? 1. So I'm going to add. Yes. And the additive property is what allows me to do that. It means that I have to do the same thing to both sides. So the additive property is what's happening right there. And I'm going to end up with that. Thank you. Is it in slope-intercept form? Does it look like the slope-intercept form? Y is by itself.
No.
The x is a number. Okay, you don't see the number, but it's 1. And then we're adding or subtracting some other number? Fantastic. What information is given by this? And we're almost done. This is the last bit. What bit of information is given by that number right there that I underlined in red?
Negative.
It is negative, you're right, but what kind of information is being fed? The y-intercept, because if you look at the slope-intercept form, the m gives you the slope. The m gives you the slope, which means the b gives you the intercept. So this must be the b, because it's not with the x. Okay, I'm going to zoom in real tight there so that you can see what I'm about to write, because I'm going to write kind of small. This right here you told me was the y-intercept. Do you have a definition for y-intercept? What do you think it means?
Where the line intersects the
Where a line intercepts the y-axis. This is fantastic. I'd like to change a few of the words in that definition. Keep it meaning the same, but get it so that it'll work for you for the rest of the math classes you're going to have to take. Okay? For as many times as you need to take them. All right? So we're going to say this. Where the graph of the function, basically the drawing of the equation, oops, sorry, where the graph of the function intersects the y-axis. And I want to tell you right now that so far we've been using intercepts and we've been using intersections as things that kind of go through other things, right? Because this line goes through the y-axis, it crosses it. And I want to tell you right now that this notion of intercept doesn't have to go through. It could totally go right up to it and go, oh my God, a y-axis, ah, and turn around and run away. It can bounce. And it's still considered an intercept because it intersected, it touched. Okay? Yeah.